All right, my friends, welcome to today's micro teach. Today's lesson is going to serve as a review for everyone. So for that reason, we'll use discussion as our strategy. And that is going to be sure to think critically about graphing to solve for systems of linear equations. And this will also be an opportunity for you to interact with a partner. So remember your key social skills and practice considering your partner's input. I'll expect you to work to answer questions with your partner, and the questions will actually help guide your discussion. So among other things, I'll circle around to observe how you discuss and include each other's points as well as counterpoints. Also remember to pay attention to one another's nonverbal cues. All right, let's go ahead and get started. So today's objective is given a discussion sheet including questions about simultaneous linear equations. Students will discuss and answer all questions with a partner with at least 85% of the class scoring at either the proficient or mastery level as measured or assessed by the formative assessment using the corresponding directions, answer key, and rubric. So as we kind of graduate out of discussing simultaneous equations, just keep in mind that simultaneous equations are a system of equations that are all true together. Simultaneous equations can also be used, though, to solve everyday problems, especially those that are more difficult to think through without writing anything down. One such application comes under planes, trains, and automobiles. The same formula that is used to calculate running times can also be used to determine speed, distances, and time duration when traveling by car, plane, or train. That is if you want to know the values for unknown variables in your travel situations. In the air, an air traffic controller can use simultaneous equations to ensure two airplanes don't intersect at the same time. All right. So remember that when it comes to our system of linear equations, we've dealt with three ways to solve for those already. That can be through graphing, substitution, or elimination. So based on your previous work, we needed a little more practice with graphing, and so that is with today's micro teach in mind. So as before, here's an example shown in this upper right-hand corner of the screen, where we see that there's a system of linear equations with a single and unique solution. So we know that because those two lines intersect at one and only one point. Now, as we look down at our second example, notice that there's actually two arrowheads there. One is in red and the other is in blue. That's because there's two lines that overlap directly on top of one another. When that happens, graphically speaking, that's an example of infinite solutions. So in our third and final example, this is showing you two lines that don't actually ever intersect with one another. So that's going to be an example of no solutions in a graph. Now, with those things in mind, this video and video link is going to serve as our in-class prep work for today's handout and discussion. It's going to be a great resource to help you brush up on solving systems of linear equations using graphing. And the video is less than 5 minutes in length. So At this point, please watch this video with your assigned partner. I'll be circulating around the room and give you a handout in the meantime. So the handout is going to contain questions that you will then discuss and answer with your partner. I'm excited to be able to listen in on your discussions and to see what answers you come up with. So go ahead and press pause in the video and watch the YouTube link. And when you're ready to proceed to the worksheet, go ahead and advance to the next slide. All right, now that you've finished watching that YouTube video on graphing to solve for systems of linear equations, you're now going to spend the next 15 minutes choosing all 7 questions below that you'll divide up with your partner. And your job is to choose questions that your partner will respond to as you record their answers, and questions that you will answer as your partner records. Be sure, though, to discuss any differences of opinion along the way to help one another develop a better understanding. So with 15 minutes on the clock, we'll start the watch now. And then on the next slide, I'll be reviewing my answers afterwards that I'll score according to the following rubric. Students who answer at least 6 questions correctly during the formative assessment demonstrate mastery. Students who answer between 4 and 5 correctly will demonstrate proficiency. And students who answer fewer than 4 questions correctly will demonstrate that they are progressing. So these team questions are going to be the same ones that I offer tomorrow to you individually to answer for purposes of the formative assessment. All right, so go ahead and push pause until the 15 minutes are up and you've answered all 7 of those questions with your partner. All right, my friends, so welcome back. Here's our solution set. So the first question, what was the most interesting thing that you discussed either with you as a pilot or as a co-pilot with your partner? Your answers may vary, but it should, of course, be something related to simultaneous equations and using graphing as a solution. On to question 2. What do your friends think if a system of linear equations has different slopes? Will they intersect? So the answer is, if the slopes are different, the lines will intersect at one point, or in other words, there will be one and only one solution. As for question 3, what do you think if a system of linear equations have the same slope? What does that mean about the solution for this system of linear equations? This could mean that there are either no solutions or infinite solutions. We would, of course, need to know the y-intercepts to decide between those 2 answers. For question number 4, if one linear equation is a multiple of another, what does that mean, both in terms of the lines and the solutions? This means that we have the same line and that there are, in fact, infinite solutions. Now on to question 5. What does it mean if our system of linear equations have different slopes and different y-intercepts? This means that our line intersects at one point and there is a unique solution. Question 6. What does it mean if our system of linear equations have the same slopes and different y-intercepts? This actually means that our lines are parallel and that there is no solution. And as for question 7, what does it mean if the slopes are the same and the y-intercepts are the same with regards to the system of linear equations? This means that our lines are the same and that there are an infinite number of solutions. So that being said, having listened in on your discussions, I was really proud of the way that you didn't speak over the top of one another and that you were mindful of each other's comments. I even heard a few of you able to correct one another and learn from each other. So That's the beauty of discussions just like these. So after class today, I'll record the number of correct and incorrect responses on the sheet, and we'll get those back to you tomorrow. And we'll be sure to have me hang the answers to all 7 questions on our class clothesline so we can do a gallery walkthrough and close the loop on this. All right, everyone, great job discussing, and we'll see you next class.